Hi, this is the second video update for the PCB Mill design. This time I'll record some process of the design and issues I encountered. Before continuing where I left, a quick review of a frame design. The base is 24 extrusions and a C-beam for the sides and the middle part of the gantry. I will include various plates and brackets that supports it at the end when I do the enclosure design around this frame. As everyone was recommending, I have changed lead screws to ball screws on XY axis, basically more accurate, better repeatability, better wear and torque. From a reputable vendor, the smallest I found is 1204, meaning 12mm diameter and 4mm travel per full rotation. Currently using 30cm length, because with the stepper motor coupler, bearings on each end and a ball screw nut in the middle, they take away around 12 centimeters, so in total I'm left with 18 centimeters of travel. My workspace is 24 centimeters on each axis. It's oversized purposely, so I have some dead space where the drill bit can never hit, and I could use this space to clamp in the material for machining. Positioning ball screw assembly is tricky as I need to center it, but then I need to add additional extrusions to support the plates. I can't put the end plates to the front as the guide blocks might reach the end before, and also work plate would stick out. I don't want guide blocks going all the way to the end, as if I will use the bellow covers to protect the linear rails, they need some space when they're fully compressed. I could shrink the frame design or increase the length of the ball screw. I changed the ball screw length to 40 centimeters. I still need to increase the size of the frame by a bit, but it'll work. Next question is where to position Y-axis linear rail guide blocks. They are under X-axis extrusions, which are under X-axis linear rails with guide blocks, and plates for fixing it. Plates in design are 70 by 40 millimeters, but I found a vendor that sells plates that are 80 millimeter width and minimum cut can be 50 millimeters. So to limit the amount of manual operations, I have to stick with the minimum plate size, which is 80 by 50 millimeters. So 80 millimeters on each side plus 80 millimeters for the motor bracket in the middle, it's 240. And the center of two plates for guide blocks dictates the spacing for Y-axis guide blocks. So if the rail sits in the middle, then 80 by half it's 40, then 10 millimeter to the side, it's 30 from the edge. 30 plus 30 is 60, 240 minus 60 is 180. So the guide blocks are 180 millimeters apart. Next issue I encountered is that a stepper motor interferes with the aluminum extrusion. Basically, the top of the plate on top of the guide block and the plate on the ball screw nut needs to be at the same height because the X-axis assembly will mount on top of it. I'm currently using 2020 extrusion, which is 20 millimeter, then MGN 15 guide block with the rail, which is 16 millimeter, and then 10 millimeter aluminum plate. It's also 10 millimeter plate for the ball screw nut. I saw that there are brackets for connecting stepper motor to the bearing block, but I only saw for NEMA 23 and I couldn't find for NEMA 17. So I'm using the plate to mount the motor, which is attached to the aluminum extrusion. Putting the extrusion in front of the plate will block access to screws for the bearing plate. Other way to work around this is to change the plate thickness. Options from the vendor 6, 10 or 15 millimeters. So if I reduce the ball screw plate to 6 millimeters, it will raise the ball screw assembly, include a stepper motor above the aluminum extrusion. Thinner plate will also require to use bolts with lower head. I will use ISO 4762 type. After changing ball screw nut plate to 6 millimeters, I found another issue, where now motor plate is too high and it will interfere with the structure above. Y-axis interfere with the X-axis, and X-axis will interfere with the work plate. So I need a difference between the plates on a guide block and a ball screw, but everything needs to be higher. So I can change ball screw nut plate back to 10 millimeters and a guide block plates I can rise to 15 millimeters. So everything is higher and there's still a difference between the plates. Okay, so I adjusted all the heights of the plates. So this is like 15 millimeters, now this is 10. I still need to adjust screws, but basically here you go, motor is not interfering anymore with the plate in here. Same for here. The L bracket is above all and here you go, it's 2 millimeters higher basically. So we move the plate. And oh, I actually haven't considered now. If the bolt's head, it'll interfere again, so I need to rotate the work plate by 90 degrees. Now L bracket interferes with the guide block plate, so I need to adjust the work plate size. To make sure I don't have any oversight again, I'm modeling all the screws and brackets. After changing work plate size, I have more space to play with, and the guide blocks are at the exact dimension as the motor plate with no clearance, so I'm adding 2mm clearance for all items. I did a mock-up for Z-axis using a ball screw following the same concept as ever axis, but it seems unnecessarily oversized. Installing could be difficult. Instead of using multiple plates, I would like to use a C-beam for holding all components. But if I use C-beam, ball screw nut block doesn't fit, so I changed ball screw for lead screw. I had to offset motor mountings with standoffs so I could use the front plate to mount bearings. I can also try to use stepper motor with a embedded lead screw to avoid standoffs, but then it would limit what kind of motor I can use, and it also would increase the price. So I'll just try to reinforce standoffs to prevent twisting. Since this should be a precision machine, I didn't want to cheap out on spindles or collets. I went for ABM brand. It's 1050 watts and it goes up to 25,000 RPM. Next, I'm thinking of increasing the frame size so I could move Y-axis motor forward so it doesn't stick out. Also, since my total Y-axis movement is about 20 centimeters and my work plate is currently 28 centimeters, I'm thinking of rotating guide block plates by 90 degrees so it's along the guide block, and this will allow me to reduce the work plate size from the sides. For the next video, I will do the enclosure and control system mountings, limit switches and other electronic components. Thanks for watching.